Swayam Prabha. Digital India. Educated India.
So good morning, welcome to this course on design for Industry 4.0 and the Industrial Internet of Things. So this is the introductory lecture, and in this introductory lecture we will cover the aims of this module, and then we'll go into the learning outcomes, and then we'll start discussing about design, Industry 4.0 and Internet of Things. So the three catch words which are there in the title of this course. So what are the aims of this module? The aims of this module are to provide you with a broad understanding of product design. So a very broad understanding of product design, but with a key focus on the engineering and the contemporary tech aspects of the design process. So the emergent engineering and contemporary tech aspects that are affecting product design as it is in the industry and the rest of the world today. We'll also talk about the need to inform the inclusion, integration and deployment of tech-enabled and smart products across life cycles of the product in the emergent Industry 4.0 paradigm. So how are tech-enabled and smart products getting included in the product life cycle, how they are getting integrated, and how they are actually being deployed in the real world. Okay. So we'll explore the connectivity of devices using the Industrial Internet of Things. So we'll see how normal day-to-day devices are getting connected. So previously the internet was all about connecting computers, but the Internet of Things enables you to connect almost literally everything. It could be this laser pointer, it could be this desk. You can convert almost everything into a smart device. So we'll look at how we can do that. Okay. We'll also learn about inculcating a whole life cycle approach from inception through design and deployment to recycling and reuse. Okay, so we'll take a full life cycle approach where you'll start with nothing and you'll go through the entire design process, you'll develop a product, and then you will see how it can be used. So we'll learn about that full life cycle approach. Okay, so one of the aims of this module is to develop an understanding around value, cost and usability as core aspects of any new product development process. So how does the new product development process really lead to value? What is the cost involved in creating a new product? And what about the usability of the developed product? Okay. So these are the basic aims of this module. So the aims of this module will translate into a set of learning outcomes for you. So you will end up with a number of outcomes from going through this course. The first will be that you will be able to understand, critically analyze and articulate the nature of the complex and compound product design process. So you'll understand, critically analyze, and you'll be able to talk about the complex and compound product design process. So you'll go beyond an ordinary product design to, we'll talk about complex products, and you'll learn how to develop complex products. So at the end of this module, you'll also be able to understand the key drivers of Industry 4.0 and smart connected systems. So what is it that is driving this Industry 4.0, the fourth industrial revolution, and how are we developing smart connected systems using the Industrial Internet of Things? You'll also be able to evaluate and deploy a range of tech supported approaches and systems in the design and development ecosystem of complex products. So you'll be able to evaluate a number of tech-based approaches. So we'll talk about many different tech-based approaches, and these have been shared in the course descriptor that has been given to you, such as the use of machine learning, use of big data, the use of APIs, etc. So you will learn about a number of tech-supported approaches in the development of complex products. You'll also be able to demonstrate at the end of this module the capability to critically analyze, evolve and deploy systems thinking, systems design and systems integration. So, three critical phrases: systems thinking, systems design and systems integration. So, how do we think about systems? So, that is systems thinking. Okay. So, how does a designer think about systems, and how does he use that to then design the system, and then how does he integrate various systems to create these complex products. Okay. So, you will be able to demonstrate it. You will not only able to understand how these are developed, but you will be able to demonstrate it yourself. You will be able to create devices such as this, which I built over the weekend, okay, such as this Wi-Fi enabled smart clock, and then using that to create even more complex products. So, for instance, can I integrate the smart clock inside an air freshener and make it a smart air freshener? So, that is the sort of operation that you will be able to do, and that you will be doing in the framework of a practical project. Okay. And finally, you will also be able to use appropriate advanced analytical techniques to review possible solutions to problems and engineering aspects of product design and development. So, you are going through design theory, you are going through design practice in other modules, but you are learning various aspects of design there, but here we will focus on the engineering aspects of product design. Okay. And you will be able to use some analytical techniques, and we will talk about the range of analytical techniques that you can use to review what are the solutions to the problems, the engineering problem. So, how are we, when you are given an engineering problem, when you go to a company, they will give you an engineering problem to work with. How can you solve that engineering problem? And when you are solving them, you will come up with many possible solutions. You will need to review those possible solutions and then used analytical techniques to select the best possible solution. So, we will learn about these techniques that will enable us to do that, and at the end of this module or the course, you will be able to illustrate this learning outcome. So, as I said, the teaching on this course is going to be very much interactive. I want you to be participating. So, we will start with unpacking the course title. Okay. So, there are three catchphrases in the course title. The first is design, the second is industry 4.0, and the third is industrial internet of things. So, let us start with the word design. What does the word design mean to you? Any takers? Yes. Shubham, what does the word design mean to you? Okay, let us see what capture everything that you are saying. So, incremental value addition. What else did you say? So, creating a product for some stakeholder, somebody who has a stake in that product. Okay, anybody else? What is design to you? What does it mean to design something? Okay, so to make a device or product or service that is of value to humans. Okay. So, the process of creating a product, is that what you wanted to say? Anybody else? What design means to you? Solving a problem, very good. And how do you solve the problem? What do you have to do to solve the problem? Okay, defining the problem. Define the problem, that is part of designing, that is good. Analyzing the problem, researching it. Analyze, research the problem. Okay, so these are all good ideas. Okay, so we'll stitch all of these together to create a definition for the word design. Okay. What about industry 4.0? What do you know about industry 4.0? Interconnection of devices that communicate with each other. So, running industries with minimal human intervention. So, how many of you have heard of the concept of a lights out factory? A lights out factory? A lights out factory is one where you can just switch off the lights and you go and everything is running on its own. Okay. So, Philips has a couple of such plants in Europe. One of them, I think, is in the Netherlands. So it is already a reality. What else? What is Industry 4.0 about? What does it mean to you? Using AI, machine learning. In, in the manufacturing sector. Any other thoughts on Industry 4.0? Anything you may have seen, read, heard? I shared a white paper over the weekend. Some of you may have read it. How many of you actually read it? The white paper which I shared over the weekend. You skimmed through it. That's good. I mean, you can actually do something. You can use a read aloud function in Adobe, and you can let your computer read the whole document through, and you can even literally sleep on your bed and listen to it, and that way you don't have to strain your eyes, and still you will get to grasp some of the content. So really the computers are making our life really easy. So what else comes to your mind when I say Industry 4.0? Computers. So why 4.0? What does 4.0 mean? Fourth industrial revolution. And what is the difference between the third industrial revolution and the fourth? That was true also in the third industrial revolution, right? Okay, so these are some good ideas. Very good. And when I say the internet, what does the internet mean to you? Connecting what? What is the internet first? What is internet? What does the word internet mean? Computers. So that's internet. What is the internet of things? Things to the internet. Very good. So you kind of have a idea about what is this all about. Very good. So that's a good starting point. Yes. Sure. Tell me. Yes. Yes. So industrial Internet of Things is about connecting the industrial components together. Okay. If I connect my household gadgets, my toy that is in my bedroom, my fluffy rabbit, okay, so that is not industrial Internet of Things. Industrial Internet of Things is connecting all of the machines, the processes that are running in the companies together. So that's that uses different protocols than connecting just because that requires different levels of security, etc., compared to the ordinary Internet of Things. So that is IIoT. Okay, so you can say broadly, yes. It's not a precise definition, but yeah, by and large, yeah. Okay, so let's unpick the word design then. What do we understand by the word design? Okay, so looking around, what objects around you are designed? What objects can you see which are designed? The chairs, somebody has thought about the shape of it, somebody has thought about the materials that will go into it, somebody has thought about how they will be manufactured, okay, the color, okay. So what else is designed? Yes, you can say that, yes, that is going into the metaphysics and other topics, yes. Sorry? Your bags, yes, those are designed. Somebody has thought about the shape of it, the material, the fabric that will go into, and the zippers that will go into, the pockets that are in it, okay. So many things. That board is designed, yes. Yes, you can say that. So, All of you are carrying smartphones, yes? So smartphone and its user interface, somebody designed that. The desk, somebody has designed that. The chair, somebody has designed that. The clothes, the laser pointer that I am using, okay? So nice little pointer. And then the keyboard that is on my laptop, the mouse, the PC casing, all of these are designed. The projector over there, that is designed, okay? So literally everything around you is designed. So what is design then? So design can be said to be a creative thinking and planning process. Design is a creative thinking and planning process that solves problems in the real world, okay? It leads to useful products and systems, okay? As many of you said, it must solve some problem in the real world. It leads to something that we can use, okay? Something that's useful to humans. And it leads to a measurable human interaction, okay? So you can measure, okay, due to the chairs, there are maybe 20 students that are sat in this room, okay? So it leads to a measurable human interaction. So again, look at these words, creative. So there is creativity in design, there is a thinking process, and then there is a planning process. So creativity, thinking, and planning. These are the key features of any design process. So design has different connotations in different fields. So think about what design means in the context of engineering. So there is engineering design, then there is pottery. What about management? Okay, so what kind of design activities that you need to carry out as a manager? Coding, okay. So all these software tools that you are using, so that is achieved through programming, and that program has a structure, an architecture to it, design to it, okay. So it's usually not just one single file, or even if it's one single file, in that file there are multiple functions, okay, and those functions, how do they relate with each other, okay, so that the code functions sufficiently. So think about what design means in the context of gaming. What do you think? What does design mean in the context of gaming? How many of you are gamers? Okay. So I can tell you, I am a Twitch affiliate, okay. I used to stream games when I was during COVID, so I don't do it anymore. I might still do it. Yeah. So Call of Duty, how many of you have played that? Okay, so most of you have played. So what goes into a design of this game? There are characters. Yes. Terrains, environments, so all of that, right? So creating a realistic war zone scenario where people can go in and operate and get some thrill out of it, and get some points and go up the ranking ladders of this multiplayer, massive online multiplayer game, right? So you get a world ranking and all of that. So all of that goes into game design, okay? So also how people will interface with it using a joystick, okay, or using AR, VR tools. So much needs to be thought of and planned. So there's so much creativity, thinking, and planning that goes into game design. So design means different things in the context of different fields. So if I say pottery, what do you think design means in the context of pottery? Aesthetics, okay. What shape should the pot be so that it looks beautiful, okay. What kind of sculpturing that you can do on the pottery so that it is appealing, okay, or what is the volume of water that that pot can carry, okay. So all of that goes into pottery design, okay. So really design means different things in the context of different fields. So how can we sum up what it means to design? So from the dictionary you can come up with the definition. So the dictionary definition of design is to decide upon the look and the functioning of any artifact such as a building, garment, or other object by making a detailed drawing of it. So that is one dictionary definition. So you may not always have a detailed drawing. If you are doing design for management, maybe you don't have a detailed drawing, but you have a schematic or something that tells you how the whole thing is going to be structured, okay. So how it's going to look like and what is the functionality that's going to come out of it. Okay. So that's one dictionary definition. The other is to do or plan something with a specific purpose in mind. With some purpose in mind, okay, do or plan something. Okay. So for instance, the tax changes were designed to stimulate economic growth. So the purpose was to stimulate the economic growth. So therefore, the government decided to make some tax changes. Okay, maybe increase the tax rate or lower the tax rate. Either way, to result in economic growth of the country. So that is your dictionary definition of design. But also it's important to note that design is something like this. What does it mean? When I show this figure, what comes to your mind? Yes, very good. So iterative process. Design is an iterative process, okay? So eventually you come to a smooth continuum, but you go through all of these squiggles, okay, to get there. So to design is to plan how a product or service will look and function. How a product, could also be a service, how will it look and function. And there is a process involved in designing, it's called the design process. It follows the process of exploration of problem, finding solutions to this problem, and then executing on the adequate solution. So you explore the problem, you find out what that problem is all about in the first place. So that is critical, and many times designers miss this point, that they need to explore the problem first, not jump to a solution straight away, then go about finding the solutions. And once you have found out the solution, don't stop there, execute it and come up with the final product, such as this IoT smart clock. Okay. So all three of them: exploring, finding solutions, and then executing. So let's understand design in the context of a simple problem, the ice cream scoop problem. So here you can see, this is a gentleman with the name Matix, and what is he trying to do? He is trying to scoop out ice cream from a tub. And what do you think will happen? Oh, that's good. So this, if he tries to take ice cream out of this tub using a normal spoon, then he will probably end up with a bent spoon like that. Okay. So there is a problem. Okay. So there is a gap that he needs to address, and to do that, what he does, he decides he will make something himself. So he sketches something like this. And what are the characteristics of the sketch? So you see here, it has a wider opening, okay, and it has also a stronger, okay. So then, yes, so he has made his first sketch of a prototype device that will enable him to solve this problem of getting the ice cream out without bending the spoon, okay. So eventually he comes up with something like this, okay. So this is a crude device that he develops, but it does enable him to get the ice cream out of the tub. So you can see here, this is a metallic thing with this wide area here that he can use to scoop the ice cream out, okay. So what does it mean to design? So to design means to plan something that can solve a gap, okay. Here the gap was that the spoon was getting bent when he tried to take ice cream out of the tub, and then to produce that artifact. So this is the designing bit and this is the manufacturing bit, okay, that enables him to solve this gap, okay. So designing involves sensing the gap. So all of you, when you will go about doing a practical project, you have to find out what this gap is first, okay, and then based on that you define the problem, and once you have defined the problem, then you need to explore alternatives. So this is his first cut device. Of course, this will not sell in the market. So as he refines it, eventually he will come to the ice cream scoop that you get in the supermarket. So, explore the alternatives, then select the best plan which is feasible with the materials that you have with you, and then execute the plan. Okay. So, what is not design? What do you think? What is not design? Who is this? Is this a design? How many of you think it's a design? How many of you think it's art? Okay. How many of you think it's both? Okay, so opinion is divided. Okay. So design is not art. Okay. So often the boundary between art and design is confused. Art is about creating something that conveys or expresses emotions, ideas or feelings of the author. So is a Mona Lisa smiling? Is she happy? Is she unhappy? How many of you think she is happy? How many of you think she is sad? Okay, so we don't know. So art is subject to the interpretation of the viewer. So that is what distinguishes art from design. Okay. That is not to say that art doesn't have an influence on design. Often may have a strong influence on design. Because art is all about aesthetics, isn't it? So it conveys a different message. So art conveys a different message to different people depending on many factors, and it may also depend on their mood. Okay, so maybe you are feeling very hot in this room and you think she is frowning, or you are feeling joyful because it's your first day at IIT Kanpur, first day of lectures. You are thrilled with all the education that you are getting, and so maybe your mood is happy and you think she is smiling. Okay, so the Mona Lisa painting is a good example to illustrate this. Some think she is frowning, others argue that she is smiling. So another one here. So this is by a gentleman known as Scott Kim. You can go on his website, scottkim.com. So see, this is nice calligraphy, isn't it? What does it read? Okay. And what does this read? Okay, so if you read this from the bottom, what does it read? Yes. Yeah. So what about this? If you read it from the bottom, okay. So is this art or is this design? It depends. So if it is used, let's say, on the laptop to identify which way is the top and the bottom, so maybe it is design. Okay. So if it doesn't have a use, if it is just for beauty, then it's probably art. So I'll leave it to you. So I'm not saying one way or the other. So I'll leave it to your imagination whether this is art or design. But definitely go on Scott Kim's website and you can see some of this fabulous calligraphy that reads the same this way or that way, if you look at from the bottom and from the top. Okay. So what is not design then? So we spoke about art being design or not design, okay, and that art may have an influence on design, but also there are other things that are not design. So engineering, for instance. So engineers deal with predictable factors like a concrete beam, right? A concrete beam, you can predict more or less what it will do if you subject it to a load. Yes. 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 So yes, but these factors are predictable, right? And we know how a beam. So what is, so let's actually understand this a bit more. Okay. So engineers know how a concrete beam will behave, right? You already know. You have been taught in theory. Okay. So do you have to actually design it? Well, it depends how you use the word design really. So what engineers do is integrate different parts of the product to work together. Okay. So but designers deal with unpredictable factors. So it depends. So how you frame your problem, the same problem of creating a concrete beam may be called design or not design. Okay. But if you all you have to do is decide on the length, breadth and the thickness, okay. Then that's using equations that you know very well how they work, and so that is not exactly design, okay. Yes, so actually that's the point, yes. So the word design in the context of the problem that you define, so it depends on how you define the problem. So if all you have to do is uh, put in a load and the software tells you the length, width and the height of the beam will be this, then you have not done any designing. All you have done is you have placed a load into a software that uses some equations that are well known, okay. Yeah, so then you, yes, if you have to select which, so that's again selection of the cross section, right? So using known formulae. So where is the design in that? If you add elements to it to define the problem as saying to improve the human experience of using a concrete beam, then becomes a very different problem from using known mathematical equations to come up with the dimensions of the beam. So there are two different problems, okay. So the way you define the problem, that becomes a creative, that requires creative planning and thinking process, and that is when we can call it design. But if it is all about figuring out what are the dimensions of a beam whose cross section we know, in that case that's just engineering, that's not design. Does that make sense? Let's reflect on it, we can have a debate on it. I'm not saying one way or the other, I'm just trying to let you think about what is design and what is not design, okay. So have a reflection on it and we can have a debate, okay. So designers deal with unpredictable factors like humans and their emotions. They make the interaction between the product and the humans better. So designers do something beyond what engineers do. So engineers may use factors of safety to create the design of a beam, okay, but that is not design, okay. So engineers may come up with dimensions, but that is not design, okay. So designers go beyond what engineers do. So they do different things than engineers. Okay, you may say a designer does more or engineer does more. We can't argue one way or the other. They do different things. Okay. So one of the key role of the designer is to make the interaction between the product and the humans better. So you want to be improving, solving a gap, that is the interaction between the product and the humans has to be better. And that is why we are entering this era of smart connected devices, where the interaction with this simple desk or the computer or the fan improves. Okay, so when this fan starts going into its last phases, I get to know that the RPM that it's rotating at, I get a sensor reading, because the smart device then tells me, okay, it's not rotating at the value it is for number 5 or number 4. Okay, so I get that feedback. So that is making the interaction between the product and the humans better. So does that mean that the designer, you as a designer working in a company, cannot code? No, a designer can code, and also an engineer can design. Okay, engineer also uses a design process, as well as a designer uses engineering techniques such as programming. But when a designer codes to production, he will no longer be designing. Okay, so he is not designing, but he is coding. He is doing something that is using a technique that we know. You know the semantics of a programming language. You are using it, okay, to code. So there you are not designing. But maybe when you are writing that code, you have a structure that you have decided for it. That is the designing bit, designing the code. Then you are coding it, you are programming it, you are writing the statements for I is equal to 1 to 10. So that is not designing, that is coding. So you see the difference, right? So even in the creation of the same product, you have different activities which can be called designing, the others can be called engineering. So learning the distinction between, so that concrete beam example that you are saying, so again there might be a designing bit to it, there might be an engineering bit to it, so you have to separate out. Coming up with the dimensions, that's not probably design, but coming up with the shape that the most optimal shape that will bear a certain load, that can be thought of as design. Okay. So anybody recognize this? Yes, it is the Perseverance rover. Okay. So as you can see, this is the schematic of the Perseverance rover. Maybe you're not able to read all of it, so it shows you the Ingenuity helicopter as well. And this is the rover itself with the mast, with power source, with there's a battery here, there's an antenna here. Okay, so there's a robotic arm here. Okay, and this is your helicopter with the solar panel on it. So this is telling you the overall structure, the architecture of this Perseverance rover and the helicopter, along with the functionalities, right? So this diagram is telling you all about the rover and the helicopter. So it is showing you the general arrangement of all of the different parts of this rover and this helicopter. Okay. So the process of creating this general arrangement is design. Okay. Creating the general arrangement of different parts of something that is made, that is design. The process of explicitly deciding how something will look like, how it will work and how it can be used. Okay. So you get a feel of how the rover will look like, how wide it will be, how many wheels, 3 wheels on this side, 3 wheels on that side. Okay. This will have four blades that will enable it to fly, tripod like stand. Okay. So deciding how something will look like. Okay. So that is part of design. Okay. So you want to be communicating that. For instance, our friend here is trying to design the next generation of assistive devices for humans. So for instance, he wants to devise a smart crutch. How will he do that? So he has to come up with sketches that illustrate what will his crutch look like, or his mobility scooter look like. How many wheels will it have? How big it will be? Okay, so creating that sketch, creating this general arrangement is part of design. Okay. Also thinking about how to communicate the design and present it for others to understand. So you see this schematic gives you an immediate snapshot of what the final rover will look like. So you get an idea for it and you can decide one way or another whether it is something that will work, not work, whether it's something that you like, don't like, whether you think this could go on Mars or not go on Mars. So immediately you get a visual impression and your brain is able to think about whether this device will do the job or not. Okay. So design is about communicating this thinking and presenting it for others to understand easily. Okay. If you have a very nice design in your head, but you're not able to show this kind of a structure that is clear enough, then you're not able to present your design for others to appreciate and then make the most use of it. Okay. So simply put, the design process can be broken down into 2 phases. One is knowing what the problem is, and that is where many people struggle. They don't know what the problem is and then they are trying to solve it before they know what the problem is. Okay. So knowing that my problem is to run a rover on the surface of a planet that is fourth from the sun, that is knowing the problem. And in what area will it operate? Maybe it has to look for signs of ancient life. So defining all of that is knowing the problem. You need to know the problem first before you can solve it. Because only when you know the problem that you can devise the correct solution. Okay. So a significant amount of time needs to be spent in knowing the problem, and once you know the problem, only then you go about solving it. So really you can even further break it down. So you start with a challenge such as running a vehicle that is man-made that will run on the planet Mars. That's your challenge. So what you do is you go through a discovery phase, okay, in knowing the problem, and then you define the problem. And that gives you a problem definition, and after you've got your problem definition, then you develop the problem and create all your concepts, and these concepts then are sorted into the best possible concept that you can deliver on. So you deliver the final concept and that gives you a final outcome. Okay. That is the solution to this challenge. So you can really break down the design process into 4 Ds: discovery, define, develop and deliver, and that is known as double diamond. So, this is diamond number 1, this is diamond number 2, okay, 2 diamonds. So, what does the discovery phase entail? Well, the discovery phase consists of identifying the problem, researching and understanding the initial problem. So, really a thorough research of the problem is needed. Okay. So, that will give you some output here. Using that output, you define the problem, where you limit and define a clear problem to be solved. So, you really define it with some specifications, okay. So, and a point of view statement. So, that gives you a clear problem definition, a statement that tells you, okay, the goal of my project is to create a rover that goes on Mars and searches for ancient life. So, clear point of view statement, okay. So, you define the problem, then you come up with concepts. So, focus on and develop a solution, okay. You develop this solution and create lots of different concepts for what can work on Mars and what cannot work, and then you select and you test and evaluate, ready the concept for production and launch, okay. So, 4 Ds making up the double diamond process: discovery, define, develop and deliver. Never forget it, okay. So, this is crucial. This is based on the design council and it has become quite popular. It is not the only way to look at the design process. The design process has also been articulated in many other different ways, and you learn this in your other courses as well, where you define the problem, you do some background research. So, the background research helps to define the problem, okay. So, it is a two-way process, and then having done that, you specify the requirements of your solution, you do brainstorming, evaluation and choosing the solution, developing and prototyping the solution, testing it, then checking whether it meets your requirements, and finally communicating the results, okay. And the crucial bit is this. What is this? Yes. So, based on the data that you get from your initial prototype, you make design changes, test again and review the new data. Pretty much the same thing, but laid out structurally different, okay, but essentially another process flow to achieve your desired solution to the challenge problem. So, there are some key design principles that we need to adhere to. So, the first thing is people, okay. So, you need to put the people first. So, you start with an understanding of the people using the service, okay. So, eventually the product that you are designing and you are developing has to be used by somebody else or yourself, okay. So, you need to have an understanding of the people using the service, their needs, their strengths and their aspirations, okay. So, what do the people need, what are their strengths and weaknesses, and what are their aspirations, okay. What do they aspire from this product, what do they want, okay. So, put the people first, think about the people first. Secondly, as we saw, we need to communicate our ideas clearly. So, communicate visually and inclusively. So, one of the things at the end of your MS program and throughout your MS program, you should pick up these skills of being a good visual communicator, and also you need to think about inclusivity, okay. So, what does that mean? The people are of different backgrounds, they come from different cultures, different races, they speak different languages, they are of different heights, they are children, they are older people. So, think about all the different types of users of your product and go about designing a product accordingly. So, what uses the product which somebody who is blind cannot use? So that blind person doesn't get to use the product. So, if you have intended a product to be used for everyone, then think about how can that blind person also use that product. So, that is thinking inclusively, okay. So, communicate visually and inclusively. So, help people gain a shared understanding of the problem and ideas, okay. So, when you can create some sketches of so when you are working in a group, you will create sketches, right, and those sketches will help your other group members appreciate what you are thinking, okay. So, communicate with that good visuals and also include everyone, okay. So, when you are working in a group, also think about all your other group members, what might they be thinking, okay. So, think about them. So, how will they think about your sketch, your design. So, communication is within the design team and also with outside the design team. The third thing about design is collaborate and co-create. So learn how to work together and get inspired by what others are doing. Okay, so working together is not easy. Okay, so some people get together and make great products. Others, they just fight all the time and complain. Okay, so learning how to work together will help you to co-create the products of the future. So learning how to work together with people from different backgrounds, different parts of the world, learning how to work together with people with different disabilities, etc. So that is part of being a good designer. Okay. And the fourth thing is to iterate, iterate, and iterate. So that is because you will find that, so the last time we tried to land a spacecraft on moon, it failed, right? So because they did not spot some errors with the program. So spot errors early, and that will help you avoid the risk, and also that will build confidence in your idea. So do not be afraid of challenging the thoughts that are there within your team. So who uses the design process? So the design process is used by a wide variety of people: architects, engineers, scientists, designers, process engineers, user experience designers, software specialists, social scientists, entrepreneurs, and so on and so forth. So all sorts of people use the design process. So because you're studying design doesn't mean you will end up being a designer. You might end up being any of these, and you might still use the design process. So design process is valuable to you regardless of what stream or profession you choose to follow in the future. Okay. And why is it helpful? Because the design process helps you break down a large project into manageable chunks. You can really take, okay, the process of making a rover on Mars, you can break it down into small chunks which you can manage. Okay. So going through the double diamond process, you break it down and discover, okay, and then define, then develop, then deliver, and then within discover you can define some tasks, and that's how you break down the project into chunks that you can manage, and you can allocate each task to an individual, okay, or resources. Okay. So it helps you break down the project into manageable chunks. It helps you solve a variety of problems. Okay. So by following the process, you are able to solve a large number of problems. It sets clear expectations. Okay. When you go through a design process, you come up with some specifications, some requirements. Okay, so it gives you some targets. So by the process of questioning, you set very clear expectations of what your final design will achieve. It also helps you improve the teamwork. Okay, so by following a structured process, you know, okay, there will be 4 phases. Within that, there will be so many tasks. You can give it to individual team members, then all the team members feel like they've got 25% of a task if it's a 4-member team. Okay, so that helps you improve the teamwork. Otherwise, one of them is complaining, I have to do everything, and the rest are getting credit, right? So because there is a process in it, you can actually break it down to manageable chunks, and you can allocate hours to each. So everyone feels that it is a just process, and that helps you improve the teamwork and improves the alignment. You bring your strong suits into the team, and then you gel together to create that final product. Okay. Also, the design process helps you reframe ill-defined problems. So if there is a problem that is not properly defined, then you can find out the gaps, the holes in the problem, and define it so that you can solve it with some specificity. And finally, it helps you create efficiently. So it improves the efficiency in creating a product. So instead of spending several years on making a Mars rover, you may cut down the time of getting to that rover to 2 or 3 years, so manageable time. It also helps you meet the user and business needs. So you are stakeholders focused. So you are able to cater to a certain user. You are able to cater to the business need of your company. So having that empathy with the user, feeling what the user feels, that is what the design process helps you do. By following the process, you are able to feel that empathy with that user, because you spend a lot of time in discovering the problem and defining it, where you try to understand the user needs. Okay. So finally, it leads to happy users. Good. So collaboration matters in design because it gives you a fresh perspective. You don't end up with a tunnel vision. It gives you ideas from many different team members. So if you're in a team of 4 and you're stuck in a certain range of thinking, oh, this can't be done. Then somebody else comes in with an idea that opens up your mind. Okay, so that is getting rid of the tunnel vision. So you get out of the tunnel and you start thinking. You spread your mind a bit. Okay, and it helps you leverage strong suits. So people of different backgrounds, electronics engineers, mechanical engineers, civil engineers, architects, textile engineers, everyone comes together and they bring in their strong suits, and that is how you create a dream product. And finally, you create a safe space where you have each other's back. Okay, so good teams will come and tell me that, well, they will never say anything that makes their team member look bad. Okay, and they will. So if somebody was sick, they will not come and report to me, oh, you are sick and all of that. They'll say, we did it all together. This is our product. They will use we, our, instead of my product, my marks, etc. Okay. So we'll end up with a bit on the industrial revolution. So we talked about. So we have now sort of unpicked design. Okay. We'll not get into a lot of the other two phrases because there are lots of lectures to follow on that. But essentially what has happened is we have gone into an era of the smart factory, autonomous systems, Internet of Things and machine learning. Okay. So we are doing a lot of AI in Industry 4.0, we are doing a lot of connectivity of ordinary objects. We are going towards more autonomy, which means these machines can operate on their own without any shop floor workers, without any humans. Okay. So full autonomy, that is the dream, and of course a factory that is smart. So before something fails, you know in advance it will fail, so you get the replacement fan in advance, not after it fails and people have suffered for 10 different classes. Okay. So that is Industry 4.0. That's where we are heading. We have not achieved it. We are in the middle of it, but it was preceded by 3.0, which was all about automated production. So automated production was already there in 3.0, using robots to do manufacturing. That was already there for the last 20-30 years. Okay. Computers, IT systems and robotics. So that was all in Industry 3.0. For that, of course, mass production, that was Industry 2.0, and this of course is the first industrial revolution, which began sometime in the 18th century when the steam engines, etc. were rolled out. Okay. So briefly about Industry 4.0 to get you excited. So it's all about autonomy, so autonomous robots, a lot more simulation, creating the digital twins, which are complete images of existing machines. Okay. System integration, Internet of Things, securing these machines. Okay, that's important. Cyber security, because once you put everything on the internet, it can get hacked, and that can lead to disastrous consequences. Okay. Computing in the cloud. Okay. So being able to store in the cloud instead of physical devices. Additive manufacturing, creating products in your own backyard using 3D printing, using AR and VR techniques, which I will cover in the next term, and of course big data. So all of these come together, they create the Industry 4.0, and indeed it is used everywhere in manufacturing. It's used for improving supply chain management process. It's used for doing preventative maintenance, knowing that this fan will break down, so doing maintenance on it in advance. And it is being used for tracking and optimization, tracking the devices as they go through. So the Boeing aircraft is flying all over the world, tracking all of its systems throughout, that is being enabled through Industry 4.0, and as a result optimizing all of these systems. Okay. So benefits are in terms of improved productivity and efficiency, flexibility and agility. We will talk about this in greater detail in the next class. You get a better customer experience, you get opportunities for innovation, and also we are heading towards a more green and sustainable world. Finally, the Internet of Things. Internet of Things is nothing but the connectivity of the physical devices around the world, and they are all now collecting and sharing the data with each other. Okay. So the example here, of course, it can be any device that is in your house, a light bulb, can be a motion sensor or a thermostat, can be as fluffy as a child's toy, or it could be a driverless car. So all of these, the jet engine, all of these are carrying IoT devices now. Okay. So this is the clock that should get you excited, and that is where I want to end it. So this is the Wi-Fi enabled smart clock. It is looking through my ex apartment in my south of England in Kent. This is a big lake. So my apartment was looking over a lake, and this is an air freshener that I redesigned. So this has water on top that gets evaporated, and attached to it is this smart clock. And to achieve this smart clock, what do we need? We need a board like this which can connect to the Wi-Fi. Okay, so it's connected to the Wi-Fi on my smartphone. So it is a low cost, because these have become so low cost, and because we have Wi-Fi everywhere now. That's why we can dream about the Internet of Things. We can transmit this data everywhere. Okay, and so I have used a dot matrix display, and I have used some mobile Wi-Fi, and I have used a piece of code. Okay, so to get there, what you need to do is install these boards within the IDE, which is for Arduino. Okay, so Arduino is again a type of board, but it comes with an integrated development environment. You can download it for free, and you can install this particular board. You can install this board on it. Okay, so if you look at the boards manager in Arduino, you can find the ESP32 board, and once you have found it, you install the board. You install the libraries for this display. Okay, and then you install some drivers for connecting the USB port of this board to the laptop. Okay, so for each one of them you have to do some installation. Then you have to connect the input connections on this array. So there are 5 input connections to this array, to this board. Okay, so this board is connected to the display. So it needs power, so you supply the power. It needs data, so you connect it to a data pin of this board. Okay, and then it needs a clock to synchronize, and a chip select to select the chip. Okay, so these 5 pins on this display need to be connected to the 5 pins on this board. And once you have done that, and you have supplied power here, and you have loaded your code, with the specific pin numbers, which you can get the code from the internet literally, and then you load the code on this. Then it starts driving this. It pulls the data from the internet. So then you can even take this out. Well, it needs a source of power literally. So you can close your Arduino IDE, and it will still keep running, because it's directly connecting. This is directly connecting to my smartphone through this board, and it doesn't need to go through my laptop. Okay, all it needs is a source of power. So I can literally take this and plug it into a USB port, and if my Wi-Fi is running, it will show me the time. Okay, so if you follow these basic steps, and we'll go through it step by step as we learn more about the IoT, but this is to get you excited that these are the sorts of devices that you can create and open up your mind straight away, so you can start thinking about your practical project. Okay, so once you compile the Arduino code and upload it, then it connects to Wi-Fi and gets the time from this website and shows it on the display. Okay, so there was a lot of failure, so don't be afraid of failure. At one point of time, it was all of the LEDs on this display were lighting up. So the way you get this time displayed on it is by lighting up, choosing which LEDs to light up on the display. By choosing them, then you are able to display any text or any numeral. So if you persevere, and if you work through all of the bugs that you are getting, eventually you will end up. So with that, I would like to end this lecture. There are some tasks for you. This can go into your portfolio. So look up patents on Google Patents, examine one that excited you the most, find out what is unique about this design involved in this patent, and create a slide to explain this patent to a general audience. Okay, then research the principles of one or more commonly used design processes in the industry. So go beyond the double diamond, look at other design processes that have been that are used in the industry, and then select a product that is available in the market and recreate the design process for this product. Use sketch paper to annotate your ideas. Okay, so again here your sketching abilities will be tested. So learn some sketching, then create a presentable slide or poster to illustrate the use of design process for this product, and demonstrate your understanding of the design process. Okay, so that's the end of this lecture. So thanks everyone for coming, and I really appreciate you sitting through this lecture. hope to see you all in the next class.